Another key area is this operations technology, is these growth of the devices that get implemented in the field as far as information that needs to be managed in these devices. The engineers and operations folks are essentially replacing electromechanical controlled grid to a digitally controlled grid, and these electromechanical devices were set with a screwdriver, and they were put in place and lasted 20, 30 years, as long as the grid assets themselves, where they're being replaced with these digital devices that are microprocessor based, that require firmware updates, that require a number of configuration settings that need to be managed, and then compatibility. And so you all remember the early days of the PC, where we had to continually provide these updates and new hardware obsolescence. All those kind of things is where we're at right now with some of these smart grid devices, and requires a level of what we call operations technology governance, and which is an aspect of information management. And then finally, this interaction of beyond the meter consumer energy technologies with grid operations. And so that's kind of the vision of smart grid, is leveraging the resources that the consumers have for optimizing the grid. And so a key challenge for utility operations and engineers is understanding that dependence and building that into the information architecture that's required. If we take a look at these number of applications that utilities have to deal with, it's pretty substantial here. And this is just a footprint of some of the key applications that we'll have to deal with. And then up in the upper left here would be your outage management, distribution SCADA, where we're bringing in all of the information that's coming from the field devices in order to provide some of those that real-time analytics, real-time optimization, as well as the information that gets pushed back into asset analytics for asset management purposes, and customer information of what's going on specifically with those customers. And then if you look at the far right, there is bringing in that metering data and beyond the meter, back through the meter reading head end, meter data management, up to the customer portals, customer systems. And so you see here a large amount of data exchange between these core applications, both in real time and historical, in order to optimize the grid from a real-time operational perspective, but also a planning and part of this vision of leveraging this information to help drive the performance for the long term. And so that needs to be built on an architecture, and that's what you see down here at the bottom. It's some core technology architecture that needs to be built into some of these smart grid initiatives, and we'll talk some more about this as we go forward. So this is this graphic here, if you see in the lower right here, is a study that was done with EPRI and Telegrid, and this shows that exponential growth of information that Dave and I had already spoken about briefly. But if you just look at metering alone, you go from a kilowatt hour per month read to an interval of 15 minutes. That alone is 3,000 times the amount of data that a utility is going to manage, just the meter reading. And that's if you go over and you look at this big jump here between AMI and this programmable communicating thermostats. Essentially what the graphic does, it stacks up these smart grid initiatives and the amount of data that utilities have to manage. And so the big jump comes with that meter reading. And so that's just kilowatt hours. Now these meters have much more data available than just kilowatt hours now, as these modern AMI meters have volts and bars and power quality, power factor, all kinds of additional information that us in the engineering side love to get our hands on that information to help understand what's going on operationally from a planning perspective, engineering perspective. But with that comes a tremendous amount of data that needs to be managed. And so applications have to be able to sort through that data in real time in order to provide that safe and reliable operations. Understanding where that core information, that needle in the haystack is that's going to help optimize your grid. And then the data management, meter data management side has to be able to collect and store, interpret that data, and become a key gateway to the customers and the grid operations. All these have to be supported by technologies such as geospatial mashups and database, of course. Security is a tremendous issue now as we continue to drive grid operations and safety. Security and authentication services need to be a key part of the smart grid strategies and the information management aspect of them. And then finally, the information enterprise service bus as a way to optimize that information handling. So why do utilities avoid these kind of things typically in these initiatives is, the operational culture is, get the job done. When nobody else wants to go outside, these guys are out there getting it done. And so when you start putting in governance and controls, that's going to slow them down. So that's just the culture they come from. Too expensive, that's the reality is it adds to the cost of doing the job is the information management processes. The lack of resources takes too long. Turf wars, it's not an IT issue, it's an operational issue. Nobody really cares about a project until once it's complete. And that's kind of the key strengths of these smart grid initiatives is utilities are very project-oriented and very good at managing the cost, schedule, and scope of these smart grid initiatives. But the real issue comes is after these projects go live, how are we going to manage this data going forward? And typically, in my experience, is these technology projects, once something goes wrong, that's when this becomes real important. And so that's what we're advising. Let's make sure we get these data management issues up front. And when we talk about data management, we're really talking, first of all, about the processes of data management, understanding the business process of how data gets initiated, how it gets transferred between applications, some of the key metrics behind that. It's a manual, tedious process. It's the boring part of smart grid, if you will. Most people like to stay with the technology area, but the data management is as important as these technologies. So here's a way of managing data. A structure of information management is a discipline for structuring, describing, and governing information assets regardless of the organizational and technology boundaries in order to improve operational efficiency, promote transparency, and enable business insight. So the point of this is that no longer can you treat information as only for your benefit or only for your business unit. Information is important across your whole utility, the whole enterprise. And so we need to understand the value of that information across these other applications and the value of information management, of data management processes as we go forward